Welcome to the Properties of Matter. In this video, we'll explore what matter is and its fundamental characteristics. Matter is anything that has mass and takes up space. Everything you see around you, from logs to a bee to a car or even people, is made of matter. To summarize, matter is defined by having both mass and volume. Volume is a measure of the size of a body or region in 3 dimensions, representing the space an object occupies. Objects with volume cannot occupy the same space simultaneously. Liquid volume, from a single raindrop to an entire ocean, is typically expressed in liters L or milliliters ml. To measure liquid volume, we use a graduated cylinder. Because the liquid surface is curved, we measure at the bottom of the meniscus, which is the curve at the liquid surface. The volume of a regularly shaped solid object is expressed in cubic units, such as cubic meters, m cubed, or cubic centimeters, cm cubed, as these objects have 3 dimensions. For regularly shaped solids, volume is calculated by multiplying length, width, and height. For irregularly shaped objects, volume can be measured by the amount of water the object displaces, using the formula V solid equals Vo Vt. Mass is the amount of matter in an object. More matter means more mass. An object's mass remains constant regardless of its location in the universe, and any change in the amount of matter alters its mass. Mass is the amount of matter, constant anywhere, and measured in kilograms, grams, or milligrams using a balance. Weight is the force of gravity on an object, which varies by location and is measured in newtons using a spring scale. 1 newton is approximately equal to the weight of an object with a mass of 100 grams on Earth. This means 1 newton equals 100 grams, or 10 newtons equals 1 kilogram. This relationship allows us to easily convert between mass and weight. Inertia is an object's tendency to resist changes in its motion. An object at rest stays at rest, and a moving object continues at the same speed and direction unless an external force acts upon it. It's important to note that more mass typically leads to more weight, and subsequently, more inertia. Let's consider a question. If an object has a mass of 6.0 kilograms and a weight of 60 N on Earth, and the Moon's gravity is 1/6 that of Earth, what are its approximate mass and weight on the Moon? The correct answer is 6.0 kilograms mass and 10 N weight. This concludes Section 1. Now we will move on to Chapter 2, Section 2, where we will delve into the physical properties of matter, presented by Mr. Ishmael Etman. Physical properties are characteristics that can be observed without changing the substance's identity. Examples include conductivity, state, malleability, ductility, solubility, density, and compressibility. Density is the amount of matter in a given space and is crucial for identifying substances because it remains constant at a specific pressure and temperature. Differences in density cause liquids to form layers. The most dense layer settles at the bottom, while the least dense layer floats on top. An object will float if its density is less than water's density, and it will sink if its density is greater than water's density. To find an object's density, first measure its mass and volume, then use the equation density equals mass divided by volume. For example, an object with a mass of 25 grams and a volume of 10 cubic centimeters has a density of 2.5 grams per cc. Physical changes affect one or more physical properties of a substance without altering its chemical identity. These changes do not form new substances. Examples of physical changes include freezing water into ice cubes, as ice is still water, and dissolving sugar in water, where the sugar seems to disappear but remains sugar. Consider which phase change increases the volume of a sample the greatest, liquid to gas. Also, when asked about physical properties of candles, able to burn is not a physical property, as it describes a chemical change. This concludes Section 2. We now begin Chapter 2, Section 3, focusing on chemical properties of matter, presented by Mr. Ishmael Etman. A chemical property describes a substance's ability to transform into a new substance with different properties, signifying its capacity to engage in chemical reactions. One example of a chemical property is flammability, which is the ability of a substance to burn. When wood burns, it transforms into ash and smoke, entirely new substances with different properties. Another example of a chemical property is reactivity, which is the ability of 2 or more substances to combine and form new substances. Iron, for instance, reacts with oxygen to form rust. Chemical properties are observed only during a chemical change. Characteristic properties, which can be physical like density or chemical like flammability, are essential for identifying substances. A chemical change occurs when substances are transformed into new substances with new and different properties. Examples include milk souring due to bacterial action, or a copper statue turning green from interaction with air. Physical changes don't alter a substance's composition, like water remaining H2O in solid, liquid, or gas forms. However, electrolysis, a chemical change, breaks water into hydrogen and oxygen gases, changing its composition. Signs of chemical changes include changes in odor, color, sound, light, heat production, or foaming. Most chemical changes are not easily reversed due to altered composition, unlike many physical changes which are readily reversible.